Okay, compare competitive inhibition and non-competitive inhibition. This is topic B, objective 7.6. Alright, here is an enzyme. This is the active site, and here is the substrate. So basically what happens is that the substrate goes into the active site of the enzyme and undergoes a reaction. For example, if the substrate was originally one huge molecule, it could react and then break apart, and then its products would form two different molecules. That would be the reaction of the enzyme with the substrate. Now consider this. There will be an inhibitor that is structurally similar to the substrate, and then it attaches to the enzyme. In this situation, when the substrate tries to interact with the enzyme, it is unable to because of the inhibitor, and it becomes very sad. That is competitive inhibition. Now, competitive inhibition continued. First part is Vmax stays the same. This is kind of like maximum velocity or the maximum rate of reaction. And kind of ignore the text if you don't understand what it means. Basically, what I'm trying to say is that Vmax stays the same because when there is an inhibitor on the enzyme, the rate is not decreased. Instead, there is no rate because the substrate cannot interact with the enzyme at all. So the inhibitor, when it's placed in the enzyme, reduces the rate to 0. But then when there is no inhibitor, its rate is the same as when there is no inhibitor, which is very obvious. So that is why Vmax stays the same. But in order to have the same Vmax, you have to have more concentration of substrate, which will be the next thing we'll talk about. So here we have an enzyme, we have a substrate. This is terrible, sloppy. Anyway, substrate, and we have an inhibitor. In this situation, the Vmax stays the same only if you have enough substrate to account for that inhibitor. Well, we'll go back to that in a second. First, look at the one at the right or left. Alright, hold on. Okay, here. There is no inhibitor here, so you have two enzymes, two substrates. The two substrates react with the enzymes. Everybody is happy because they all have their little enzyme substrate couple, yeah. Okay. Anyway, the next one. You have two enzymes, but you also have two inhibitors. Because of that, you need more substrates to interact with the enzymes in order to push the inhibitor out, which will ensure that Vmax stays the same for both different solutions, so to speak, of enzyme substrates and inhibitors. Because of that inhibitor that prevents the substrates from interacting with the enzyme, you would need more substrate because the inhibitor is causing problems. So the rate will stay the same. As you can see in the top one, when there is no inhibitor, the substrate and the enzyme have the same rate as the one on the right. So you just have to increase the substrate concentration in the solution. And that is Km, which is substrate concentration. Km has to increase if you want the same Vmax for the left side as to the right side. Now, to elaborate on this with a graph, after I finish writing very slowly, we will be using a graph to just basically summarize what is occurring here. So the x-axis is the substrate concentration, the y-axis is Vmax. So the dashed line on top, as you can see, dashed line on top is Vmax. And then the dark curvy line is when the solution, the enzyme substrate solution, has no inhibitor. So as you can see, it reaches Vmax in a certain point, right? And then with an inhibitor, it will, I haven't drawn it yet, but it will also reach Vmax at a certain point. But you will need more substrate concentration because you have inhibitors that will prevent some enzymes from reacting with the substrates. So line is lower. So as you can see right here, at that point where I circled and bolded is where both have reached Vmax. But with inhibitors, you will also need greater substrate concentration, greater Km, but then Vmax stays the same.